This measures the ideal gas law in terms of the total number of molecules present. But it's very difficult to measure the total number of molecules present in a gas. It's much easier to measure the mass of the gas. But maybe there's some way we can relate the mass to the number of molecules. So to relate mass and number of molecules, let's look over here for a minute. We said that 2 grams of hydrogen had the same effect as 4 grams of helium or 32 grams of oxygen. The reason is that each of these has the same number of molecules. It turns out that if we look at a molecular level, a hydrogen molecule, that's an H2, has a mass of 2 atomic mass units, or often simply written as 2U. Helium has a mass of 4U, and oxygen 2 has a mass of 32U. So what we would like is some number of atoms that relates masses in atomic mass units to masses in a more convenient unit. So the idea is that 1 mole of atomic mass units will equal 1 gram total. 1 mole of U is 1 gram. The definition for this actually comes from carbon-12. Carbon-12 is defined to be exactly 12.000 however many O's atomic mass units. That's the mass of carbon-12. So we say that Na is equal to the number of carbon-12 atoms in 12 grams of carbon-12. Experimentally, that number turns out to be 6.022 times 10 to the 23. There are no units here because this is just a number. It's a way of quantifying how many molecules of something we have. We call this amount 1 mole. This is very much like when you go to the store and you buy 1 dozen eggs. 1 dozen is just a number. It means 12. 1 mole is just a number, 6.022 times 10 to the 23. These masses then, for oxygen and hydrogen, such as 2 grams of H2, that's known as the molar mass. It's the mass of 1 mole of your substance. So 2 grams is the mass of 1 mole of hydrogen molecules. 4 grams is the mass of 1 mole of helium molecules, atoms in this case. 32 grams is the mass of 1 mole of oxygen molecules. Well, now we can write our ideal gas law in terms of the number of moles of gas. Instead of N, I'm going to say that N, the number of molecules, is equal to the number of moles times Na. And then when I take my equation, PV equals N K Boltzmann T, this is the number of moles times Na K Boltzmann times T. And I can regroup this and call this R. It turns out that now we have the ideal gas law in our usual form, PV equals nRT, where R is equal to 8.31 joules per per mole Kelvin. Now, if you want to know how many moles of gas you have, you don't have to count individual molecules. You simply take the mass of the gas in grams and divide it by the molar mass, which is also in grams. And that will give you the number of moles.